Have you ever stopped to wonder, what was before the universe? It's a question that has haunted humanity since we first turned our gaze skyward. For centuries, philosophers, scientists, and curious minds alike have been vexed by this cosmic enigma. Was there a vast emptiness, an infinite void waiting patiently for the spark of existence? Or perhaps an alternate reality, a different universe altogether, playing by a set of rules we can't even begin to fathom? Some speculate about a cyclic universe, endlessly dying and being reborn in a cosmic dance of creation and destruction. These are just a few theories among many, each one as fascinating and mind-boggling as the next. They challenge our understanding of time, space, and everything we thought we knew about reality. So, how did the universe come to be? Let's delve into the mystery. Approximately 13.8 billion years ago, our universe sprang into existence. Imagine, if you will, nothingness. Then, in a fraction of a moment, everything. This is the essence of the Big Bang Theory. The Big Bang Theory, despite its name, wasn't an explosion in the traditional sense. Instead, it was a sudden and rapid expansion from a point of infinite density and temperature, a singularity. This theory is widely accepted by scientists as the explanation for the creation of the universe. It's the story of how a tiny, dense, hot point expanded and cooled over billions of years to become the vast, complex universe we see today. So what exactly is a singularity? It's a point in space where density and gravity become infinite, where the laws of physics as we understand them cease to apply. It's like the ultimate divide by zero error. The singularity at the start of the universe was incredibly hot and incredibly dense. It was all there was. Every bit of matter, every bit of energy, everything that would become everything, was condensed into this one point. Then, for reasons we don't entirely understand yet, the singularity expanded. And when I say it expanded, I don't mean it got bigger in the way a balloon gets bigger. I mean it stretched. Every point in the universe moved away from every other point, and it happened incredibly quickly. This is the bang in the Big Bang. As the universe expanded, it also cooled. This allowed energy to be converted into various subatomic particles, including protons, neutrons, and electrons. Eventually, these subatomic particles combined to form atoms, the building blocks of matter, paving the way for the formation of stars and galaxies. From an infinitesimal point, the universe expanded into the vast cosmos we see today. The Big Bang Theory remains the most comprehensive and widely accepted explanation for the inception of our universe, a testament to our quest to understand the grand narrative of cosmic evolution. As the universe cooled and expanded, matter started to clump together. Imagine a cosmic soup of particles, a blend of hydrogen, helium, and trace amounts of lithium. This soup was not uniform. There were slight variations in density, and it is these tiny variations that would become the seeds for the formation of stars and galaxies. Gravity, the great sculptor of the universe, began to work its magic. It pulled on every particle of matter, drawing them together into denser regions. Over time, these regions of higher density grew, attracting more and more matter, like a snowball rolling down a hill, gathering up everything in its path. Meanwhile, something incredible was happening within these dense pockets of matter. The pressure and temperature were rising, creating the perfect conditions for nuclear fusion to occur. This is the process that powers the sun and all the stars in the universe. Hydrogen atoms were being squeezed together to form helium, releasing a tremendous amount of energy in the process. This energy, in the form of light and heat, exerted a pressure outwards, balancing the inward pull of gravity. When these two forces reached a delicate equilibrium, a star was born. And around these bright new stars, galaxies began to take shape. But stars are not just beautiful to look at, they are also cosmic forges. In their fiery hearts, they manufacture the heavier elements that make up the world around us. Carbon, oxygen, nitrogen, all the way up to iron, are produced in the cores of stars. And when a star dies, it explodes in a supernova, scattering these elements across the universe. They become the building blocks for new stars, planets, and even life itself. And thus, the first galaxies and stars were born, lighting up the universe. The universe was no longer a dark and empty place, but a canvas filled with the brushstrokes of galaxies, each one a masterpiece of cosmic art. In the swirling dust and gas around young stars, planets began to form. As these stars came into being, they were surrounded by vast disks of matter, a jumble of elements brought together by the force of gravity. This was the birthplace of planets, including those in our very own solar system. Picture this cosmic nursery, a swirling, chaotic mass of dust and gas. Over time, these particles, under the relentless force of gravity, began to collide and stick together. This process, known as accretion, is akin to creating a snowball. The more snow you gather, the larger the snowball becomes. Similarly, these tiny dust particles began to come together to form larger and larger bodies, eventually forming planetesimals, the building blocks of planets. But the formation of planets is not a uniform process. The conditions under which a planet forms can greatly influence its composition and even its potential for life. For instance, planets forming close to their parent star, like Mercury and Venus in our solar system, are typically rocky due to the high temperatures that vaporize lighter elements. On the other hand, planets forming further out, like Jupiter and Saturn, are gaseous giants. The cooler temperatures at these distances allow for the accumulation of lighter elements, such as hydrogen and helium, leading to massive gaseous planets. Now let's turn our attention to our home, Earth. Earth formed under conditions that were just right, not too close and not too far from the Sun, in a region aptly called the Goldilocks zone. Here, the conditions were perfect for water to exist in its liquid state, a key ingredient for life as we know it. Over billions of years, Earth underwent numerous transformations, with the development of an atmosphere, the emergence of land masses, and the evolution of life. Each of these steps was influenced by the special conditions under which Earth formed. And so, our home, the Earth, came into existence. Its formation and evolution, a testament to the remarkable processes that continue to shape and reshape our universe. The universe continues to expand and evolve, but what does the future hold? As we gaze into the star-studded canvas of the night sky, we can't help but wonder what lies ahead for our ever-evolving cosmos. The future of the universe is a topic of constant intrigue, and while there are several theories, three stand out: the Big Freeze, the Big Crunch, and the Big Rip. Imagine a universe slowly cooling as stars burn out, leaving behind a dark, lifeless void. This is the essence of the Big Freeze scenario. As galaxies drift apart and stars exhaust their nuclear fuel over trillions of years, the universe could descend into a state of extreme cold and darkness. It's a chilling thought, isn't it? On the other hand, consider the Big Crunch. If the universe's density is high enough, gravity could eventually halt the expansion and pull everything back together. This would lead to a cosmic implosion, a reverse of the Big Bang, if you will. In essence, the universe would collapse under its own weight, crunching into a singularity. The third theory, the Big Rip, is perhaps the most dramatic. Here, dark energy, the mysterious force responsible for the universe's accelerating expansion, could become so potent that it tears apart everything, from galaxies and stars to atoms themselves. The universe in this scenario would literally rip itself apart. These theories, while fascinating, are just that, theories. Our understanding of the universe is constantly growing and changing. The universe's fate largely depends on its density and the nature of dark energy, two factors we're still striving to understand. But one thing is certain, the universe has a timeline, a beginning, a middle, and an end. And while we may not know exactly how the story unfolds, we continue to explore, to learn, and to marvel at the mysteries of our incredible cosmos. Only time will reveal the ultimate destiny of our universe. From a singularity to an ever-expanding cosmos, the story of our universe is a fascinating journey. We've delved into the origins of our universe, starting from the Big Bang, a cataclysmic event that gave birth to all matter and energy. We've traced the formation of galaxies and stars, the cosmic nurseries where elements are forged. We've walked through the creation of our planets, including our own home in the vast expanse, the solar system. And we've peered into the potential future of the universe, contemplating its ultimate fate. It's a story of creation on a grand scale, a testament to the power and beauty of nature. But remember, this is only the tip of the cosmic iceberg. There's so much more to discover, so many more mysteries to unravel. If you're as intrigued by the universe as we are, subscribe to Olapses and join us as we explore the mysteries of our cosmos.